suppose I have an inverter, something like this. Okay, and if I have an inverter, and let us consider I am giving some input to this inverter. Let us assume input is I. Okay, so input I is given over here. Okay, and let us assume the output of this inverter is, yeah, so let us assume this is O1. Okay, O1 is the output of this inverter. Now if I have another inverter, something like this, okay, and so what will happen, whatever the logic I will give here, let us assume I am giving 0, so I will get 1 at this point of time. Okay, so if I will give 0, then I will get 1, and if I am giving 1, then I will get 0. So this is the property of inverter. Okay, now let us try to see. If 0 I am giving, then I will get 1, and because I am again connected to the one inverter, so again the output will be 0. Okay, and in this case the output will be 1. Now what we are doing, and let us try, let us consider this is the output 2. Now if this output, because if we talk about the fundamental of sequential logic circuit, what we do, we connect the previous state output to the input. Okay, so this is the output, okay, of this logic circuit. Let us assume this is the combinational logic circuit. Yes, because we are not connecting output to the input, so this will be considered as a combinational logic circuit. Okay, and if it is the combinational logic circuit, so whatever output I am getting at this point of time, this will be considered as the output of the combinational logic circuit. Now if I want to make this logic as a sequential logic circuit, then what I have to do, I have to sample this output, and I need to connect with the input. So let us try to do that. So suppose if I have sampled the output and I have connected this to the input again. Okay, so what will happen? What will happen? Let us try to see. Because if I'm considering the first case, okay, first case where I'm giving input 0, accordingly I will get output 1 for the first inverter, and output will be 0 for the second inverter, and that will is connected to the input of the first inverter. Yeah, let me write 1 and 2 so that will be helpful. So let us assume this is the first inverter and this is the second inverter. And because we have connected the output of second inverter to the input of the first inverter, and input of output of the second one is same as the input of the first one, so they will match. And if they will match, then what will happen? This 0 will be connected to this 0 1. So at time t, we had given like 0 input, and we are getting the output 0 here. But because if I'm talking about t plus 1 time, again, because the input at t plus 1 time is nothing but just now, after that I have removed this input. Let us assume I'm not giving the external input. Then what will happen? Yeah, let us assume this path is breaked. So this output is directly connected to the input. So this output is actually 0, and 0 will be connected here. So t plus 1 time, again I will get the same kind of responses. So now if you see, this output and these outputs are blocked, they are latched, they are not changing their states. Okay, so this kind of logic we can call them the latch circuit. So at each instant of time, you will get the same kind of outputs. Output is not going to change if I'm not changing the input pulse. Okay, so for one time, let us I have just triggered it with the 0 to 1, and at this time period, let us assume this circuit is triggered, and then after I have removed this input, and after removing that, the logics will be latched at both the outputs O1 and O2. Okay, and if they are latched, means we can call them the memory element. Okay, so the latch means what? Even after removing the input, the outputs are always 0 and 1. Okay, so 0 and 1 will be there without any input. The output of both the inverters will be 0 and 1 respectively. And if it is like that, so without any input, I have some data at 0, O1 and the O2. What it means, we are able to store some, it simply means that even though after removing input, the data is stored at both the states. Okay, and if it is stored, what it means, they are holding the data. And if they are holding the data, what it means, we can say that this is the basic building block of a memory element in the processor or in any of the semiconductor. Okay, so this is how they can hold the state or how they can hold the information. Okay, so if we talk about if I have to store 1 bit data, so this kind of the simple structure is sufficient to store 1 bit data. Okay, either 0 or 1. Okay, so if initially I had given input 0, so I will get output at O1. So you can take output from either O1 or O2. So if we are taking output from O1, so you will consider that. So let us assume I have a circuit. Yeah, let me go to the next circuit, then I will explain you what I'm saying. Okay, so this is how the structure will look like. Now, if we try to rephrase this design again, so I have a one inverter, which is the I1. Okay, and I'm giving some input. Yeah, so I think I need to differentiate these two things. Let me write IN, so that otherwise this will be differentiated. Okay, so if I have an inverter I1, next inverter, if you see the next inverter is the output of the first inverter is connected to the input of the second inverter. So the output of first inverter is connected to the input of second inverter. Okay, so this is the same, and the output of second inverter is connected to the input of the first inverter. So input of the first inverter. So this is how the actually circuit. Yeah, this is how I have just redesigned. There is no change in the operation. It is same like that one. Okay, so I1 and inverter 1 and inverter 2. And if it is like that, so it means that we are able to hold some of the logics. Okay, so let us see here. If I have an input, okay, if I have an input, and let us assume this is the output Q. Okay, the output Q is nothing but this is input complement. And if we talk about this node, so this node is nothing but this is the if I have Q here, so this Q is connected here. So the output of the second inverter is nothing but this is the Q bar. Okay, and if it is the Q bar, so Q bar is nothing but this is equal to IN. So this is equal to IN. So the both the outputs are nothing but they are complementary in nature. Okay, so if I am considering this as a reference output, so we can say that suppose I have triggered this circuit with logic 0. Okay, so what it means, I have provided 0 over here, so output will be 1. So this Q will be logic 1. So we can say that this memory has stored logic 1. Okay, so this memory has stored logic 1. So this is how you can say. Similarly, if you have triggered this input just like from low to high, so and if you have changed like this, so at that time I will get output is equal to 0. So because you have given 1, and if output is equal to 0, this Q will become 0. So you can say that the memory which is the data which is stored in this memory is logic 0. Okay, so this is how actually memory works, and this is the real example to understand the fundamental of memory, how the memory works. Okay, so if anyone has any doubt, you can ask the question, right? So otherwise we can move ahead if there is no problem. Okay, fine. So let us try to see here. Yeah, so here we have some truth table. Okay, so suppose I have a input and some of the outputs, like we can have a 2 outputs. So what will be the truth table? So the truth table will be, if the input is equal to 0, then Q will become 1, Q bar will become 0. And if input is equal to 1, then Q will become 0 and Q bar will become 1. So this is the simple truth table of this one. Now let us try to understand like how we can say like one very important thing. I'm just quickly explaining you how it is working, how the characteristics of this kind of element looks like. Okay, the characteristics of this element is really very important to understand. Okay, so if you can redesign this structure, whatever we have, so let us see how the redesigning of this inverter will look like. Okay, so let us try to see. This is nothing but this is the inverter number 1 which we have connected here. So this is the I1. Okay, so yeah, here I have some input, and here, so let us assume this is the in 1. Okay, so let me change the color. Yeah, so let us assume this is the in, and 1 means first inverter. Okay, and accordingly I will get some output. Let us assume this is the VO1. Yeah, simply let us write O1. Okay, O1 is nothing but this is the output for the first inverter. Okay, so this is the input output pairing. Output of the second inverter should be, you have written Q. Yeah, simple mistake. Yeah, thank you. So if we talk about, if I have one inverter, so the input is IN1, and accordingly I'm getting, let us assume the output is O1. Now what we are doing here, so we are simply, the output of the first inverter is connected to the input of second inverter. So let us try to reconnect it. Yeah, so let us assume this is the inverter number 2. Okay, yeah, this is simply just, this is same like what these all are same. These all are same, just the rearrangement is there, nothing else. Okay, so this is the second inverter, and the second inverter, if I have the second inverter, so this is really very important to understand here. Whatever the output I have over here, so this is the output of the first inverter, but the same term will be treated as an input of the second inverter. So this is nothing but, we can say that this is the input of second inverter's input. Okay, the second inverter's input is same as the output of the first inverter. And if you're talking the output of the second inverter, so the output of second inverter is, let us assume it is the O2. Okay, and O2 is same as the input of 1. Okay, so this is the thing. So let us try to understand the characteristics, how it looks like. Let us assume this is the I2. Okay, so this is the things which we should know. Before I explain you about how the bistable or stable or monostable nature looks like, I just wanted to explain how the inverter characteristics looks like. Inverter characteristics looks like this one. If you are going into more detail, so I'm just quickly explaining you how the inverter characteristics looks like. And but if you want more detailed explanation, I will give you the reference, and then you can go through that lecture and you can check it out how actually this works. So I will tell you. So suppose I have, let us assume this is the input and this is the output. Okay, in reality these inverters are made of the CMOS kind of logic. So let us, the best kind of circuit, like based on the MOSFETs, you can make the inverter. You know that this is how the inverter can be made. Okay, and if this is the structure of inverter, we have already studied in initial classes. Okay, so this is how the inverter will look like. So if input is equal to 0, this will mean on state, this will mean the off state. So logic high will be transferred, so 1 will be there, and if input is equal to 1, then this will be in on state, upper will be in the off state, logic 0 will be output. So this is what we have. So suppose I am changing the, so the output characteristics of any inverter looks like this one. So the input is high for some period of time and it is low for some period of time. So this is the characteristics of input, and that depends on how we are changing the, let us assume if I'm changing the input from 0 to 1. Okay, and if I'm swapping the input from 0 volt to, let us assume VDD, up to VDD, this is the VDD voltage. So at 50% of time, like where the circuit threshold voltage cross, it will become it will change its state. Okay, and accordingly it will work. So during this time period, the PMOS was in on state, and during this time period, the NMOS was in on state, and accordingly I was getting the characteristics. I'm not going into more detail. I will give you the reference and you can check it out. I just wanted to tell you how the behavior of one inverter looks like. Okay, so this is how one inverter behaves. Okay, so suppose I have an inverter. If the input is like, the inverter is something like the 0 and 1 kind of output, you will get it out. Now let us try to see here. We know that the output of first inverter is nothing but this is the input of the second inverter, and the output of second inverter is same as the input of the first inverter. Okay, so if I try to draw the input output characteristics, then how it will look like. Let us assume this is the characteristics for the inverter number 1. Okay, so this will be the, let us assume this is the output 1, input 1. We have some input and we have some output, and we are getting some input output characteristics based on the first inverter. Now let us talk about the second inverter. If I have a second inverter, and the input output characteristics will again be like this. So let us assume this is the input 2 and this is output 2. Okay, and the behavior will again, it will be same, like because it is inverter again, then the behavior will be something like this. Okay, now if we see, if we try to map this axis, okay, so this O1 is nothing but this is same as the input 2. Okay, and this input 1 is nothing but this is same as the output 2. So I need to map these axes. So if I want to map this axis, how, let us see how it will look like. Okay, so they will simply look like, let us assume the first axis here, I'm considering this is the input 1, IN1, and this is same as the output 2. Now if I want to map the second one, so this will be like, if I have an input like IN1, then I will get output 1, and accordingly if I have output 2, then input 2 will be here. So this is how we can map these things. So if I'm considering the first case, okay, if I'm considering the first case where I have this input 1, then the characteristics will look like this. Let us try to make it. Okay, so this is how the characteristics will look like. Let me make it proper. Okay, so this is how the characteristics for first inverter will look like. Okay, now second inverter characteristic is also similar, but if you see, this one is the axis for the input and this one is the axis for output. So the characteristics will look like this one. Let us try to make it with different color. So the characteristics will be something like this. Okay, because this is the lower value, and I have to just flip in the board, flip the axis, and then I will get this kind of characteristics. Okay, so now let us try to understand how we are getting the stable points and unstable points. In more detail, you can get it somewhere here and there. I will tell you from where you can get it. But for now, let me tell you what are some important points of consideration here. Okay, so if we talk about this point, here at this point, one of the output is 1 and one of the output is 0. So this point, we can call them the stable points. Okay, this is the stable point. One point is here where the another of output is logic high and one of the output is 0, where we are getting the unstable point. If you see this one is the unstable point because the input is changing, like input was stable for some period of time at this stage, but here the input was not stable. In a slight change, input will either reach to this one, or the output will either reach to logic high, or it will reach to output logic low. Okay, so these points at the middle, these are the unstable points. The point at this one, this is the unstable points. Okay, so these are some stable points. Yeah, so this is the stable, and this is the unstable points. Okay, and all other things, like just if you want to understand this concept in more detail, you simply refer this lecture, and you will get to know all these things. So I highly recommend, please refer this lecture. Yeah, you can find in my YouTube only, and you can just go through it, and you will get different kind of fundamental of this stability. Okay, from a gain relation and stability relation, so all these things kind of relation you can get from here. So I will highly recommend, just consider these things, just go through it, and you will be happy to understand like how actually flip-flop works, or how actually memory store the logics. Okay, yeah, I will share with you. Okay, so this is how the latch works. Now let us try to uh, extend our analysis further. Okay. So I'm not going into more detail here, because I have already one lecture on this, and because it takes 1 hour lecture, and I think it is not that much important for digital design part. But yes, if you want to really understand how actually memory works, how it relates, how it affects the gain, how it affects the performance and the stability, all these things. So this is really important that you should go through it, and you will be able to understand each and everything. Okay, so